So today I'm going to plan to write sort of an shellcode execution loader using AI or abusing AI or however you would like to call it. I plan to mainly use GitHub Copilot because this is what I mainly like to use for coding in general. It's super useful. It's super helpful. You will get a lot faster with some tasks by using that. Yeah. And in the very end I start to plan, or I planned to start from absolute zero, so nothing. You see there is no code at all. And I plan to do it in some language I'm rarely to never using, because then I need to more... I don't need to, but I want to avoid using Google or similar engines, and to try to do all the stuff with AI only, to get all the code, all the troubleshooting steps, all this kind of stuff from AI, so that in the very end the loader should be written nearly fully by AI. Of course this will not happen like this, but let's see how far we come. I think my goal for today would be to get a Havoc daemon to run on this system here with the loader without being detected by cloud or normal protection from Defender, and starting from zero. So that's the plan. As I'm typically using the languages like NIM, I just started for 3 or 4 months coding in Rust. But now I'd like to do it different. If someone read my blog posts in the past, I was always trying to not do something with C or C++. But now I'd like to do it with either C or C++. I think there's already 2 people wrote something into the chat. What would you like me to do? C or C++? I don't think the difference is super big. NIM was always a little bit more near to C, not to C++. C++. I was hoping for you to type C because it's only too near to NIM, but I can also try to do it in C++. I can do it in C++ if you prefer to do that. Okay. We start completely from zero. Which imports would I need for an C++ binary to read a file from disk, allocate memory, write the disk binary to that memory, and execute it from there. First thing we obviously need is some imports. And it looks like in C++, I never did anything in C++. In C, I was writing shellcode in C, but I didn't do anything in C++ so far. Looks like we could use fstream, vector, and we need Windows. This is obvious, at least for the Windows APIs. Cameras, oh, okay, that's bad. Let me check if I can change this. Is it better like this? Now I'm somewhere in the middle of the picture, if it worked. Okay. Yeah. On the right corner. the right corner is the chat for me. At least you should also see the chat in the right corner. Let me... No, not bigger. I'm far away from being a professional streamer. Far away from. No, it won't get better. Oh, it always gets worse. Let me try to at least resize this for a little bit. Bad idea. Okay. Yeah, so we start from 0. Do we need namespace standard? I don't know. I have no clue. What I typically do when using GitHub Copilot or I'm always using GitHub Copilot, to be honest. I started using ChatGPT at some point for coding, but when I noticed that there is a chat in GitHub Copilot, yeah, I don't need ChatGPT anymore. We can basically do anything with GitHub Copilot, and it's much better, faster content, better quality of content than ChatGPT. Okay, what I typically do, or how I typically do it, is I'm writing a comment which states what I want to do, and then I get the code provided by GitHub Copilot. So if I state we need a function that takes a string as input and returns a byte array with the contents of this file from disk, reading the file should be done via Windows 32 APIs. Then I can go for just enter here, and I should get normally the code, or the code from GitHub Copilot. Seems like it's not yet ready to do that, so I'm going for the chat for the moment. And as you can see, it returns to me there is you can create file, use create file, get file size, read file functions, and then we get a vector byte. This is C++ specific, I guess. Never saw that before. And we're just going to take this for now, and we will see if this works later on. So we have a function now which reads a file, which has a string as input, a file path, and which returns a byte array. Create file is used first, get file size, read file is used, we write this file content into a buffer, and the buffer is returned. This is our function for reading content. As simple as that. So, and now this is the recommendation from GitHub Copilot already. Now it gives me the hint that I can or should create a main function, and I can use some file, check if it's empty or not, and or use it directly. So this is basically the prompt which I can accept already here, or I can say I want to have an alternative. If I say I want to have an alternative here, okay, it's just changing the comment here. But we can also say, okay, we need a main function anyway at some point. So let's just accept this. We will need to adjust this path later on. My plan would be to read the Havoc daemon shellcode from disk, put it into memory and execute it first. Maybe we should or need to also add encryption. If we want to add encryption and if we want to encrypt it before actually decrypting it, putting it into memory and executing it, we would also need to have an encrypt function. So we can say, so if it's going to be a little bit like a packer, then a packer typically has some different components. One component is the encryptor, which takes an input file, which encrypts it, which outputs it to a file or to a byte array or whatever. And then we have the loader code, which actually takes this encrypted content, decrypts it, and executes it in memory. We'd like to have a main function here, which reads the user input file and encrypts this with... We are just going for XOR for the moment. This is the simplest solution, I guess, as I want to get it in time. And now we already see there is the main function, but it's not yet reading it from the user input. At least I don't see anything which could be related to user input. No. The user input argument 1 is the file name to encrypt, and the encrypted file, oh, that's okay. Okay, now we have a dedicated encrypt function, or it wants to give us a dedicated encrypt function. And it just encrypts, or it does XOR with 1 or 5. This is not good enough for me. I don't want to do just XOR with a single... the XOR should be done with no, not random key. We're using a hard-coded key. Key of length 32-bit. Let's see what he wants to identify, push back. No, this is not what I want to do. Oops. So argc, argv. This is our key. This looks at least better from everything that was recommended till now. I don't know if it's okay in C++ to use the imports here in the main function, and if it's okay to specify them in the main function. Not sure about that. But this key looks, for me, this code looks for me much better than the one which was recommended before. File open, file, read, close. Then it's doing the encryption. So for me this looks like it could already be working. We can just test this. Let's save it. We're going to save it in a new folder. AI Maldev. Encryptor CPP. Hope it compiles. If it doesn't compile, we need to fix some stuff. But this is now also the thing. If we say, okay, we are someone who's no clue of nothing, and well, this is a simple solution, at least. Maybe we should use this import here, because it's missing. This is obvious. Looks like the definition of our key is wrong, or there is no correct conversion, like there is a missing cast or something. But what we can also do, if we're not sure what is happening, we can also put that thing into the chat and just ask for GitHub Copilot fixing this code. Okay. And now it tells me that these values are not in the range for char. Unsigned. So we need to use unsigned char instead of char. This is the solution. And we also need to change the key pointer to unsigned. Let's see if this already fixes it. At least it compiles. There's the question. Yeah, we could use something like this whispers or similar. Maybe it depends on the time. I mean, of course, it would make sense to use direct syscalls or indirect syscalls to execute it. But due to me having now like 1.5 hours maybe for the stream, and I want to have a working solution in the end, I will first try to do it with Windows 32 APIs, and then if we have enough time, I'm going to switch to indirect syscalls or direct syscalls. But I would not want to use this whispers 3 here, because this whispers 3 is typically flagged with signatures. The sound is cracking. What do you mean with the sound is cracking? I know that I have a super old computer here which is loud, so this could be sounding like a plane. But I hope the sound, at least from a microphone, is okay. So, sounds like some jitter. Okay. Retro movie. Is this a good thing or a bad thing? Retro movie could also be a good thing. So let's see if this encryption works. We have our encryptor, which is nearly fully made by AI only, and we have a daemon here. And if it works, then we should have an encrypted daemon here by now. And I would say this looks good. We can compare these two. So in this session we will, like always, just think of first what the AI is giving us as output, that this is correct. We just go for trial and error. I would just like to see where we land with this approach. Yeah, and if we see now, the daemon here is the plain daemon. This one here is completely different, so I guess this code which was provided works perfectly fine to encrypt our daemon, so that we avoid any signatures for the daemon here. Looks good. So we have an encryption function. With this encryption function, we should be able to also build a decryption function in the loader. So this here is more or less the packer. In terms of, it encrypts the file, it makes an encrypted, it puts an encrypted file to disk, and here, which will be the loader later on, we would need to read this encrypted file from disk. We would need to decrypt it. Hard-coded key is used. And now we are just going to say this is our hard-coded key. Super simple. Then it knows which key we want to have. XOR is used for decryption. We could also copy paste the code from here, but maybe let's see what it provides. Input parameter is an byte array. Return value is nothing. We don't need a return value in the very end. So decrypt. It says this is how to decrypt. Key pointer, key, buffer size. Looks slightly different. We don't have this check for the \0 in the end in the other function. Our encrypted content may also not end with \0. Not sure if this will work, but as I said, we will just trust in AI here for the moment. Just to see where we land with this approach. So our input, this is what we already got, is the encrypted daemon. We can put it into another folder later on, but this should not be, this is an excluded folder. We will put the loader and the payload in another folder later on, but this should not be flagged anyway because it's encrypted. Okay, decrypt the buffer. So this is, now we call our decrypt function. After reading it into a byte array, we call our decrypt function, which uses the hard-coded key, decrypts it, and then our buffer contains the decrypted content. Allocate memory for the decrypted buffer. With virtual alloc and read-write permissions. So we're going to use virtual alloc to allocate memory for our buffer and its size. We are going to do it with page read-write permissions first, because we need to write the buffer into this memory region. Write buffer into allocated memory. Oh, this is nice, because we don't use any Windows API at all, but this will just be copied byte by byte into this section. If we use as less Windows APIs as possible for the loader, it's less likely to get flagged. Yeah, after doing that, we need to execute it. We have different options here. No, we first need to change the page protections. Change page protections of to read execute. First allocating with read only, wait 5 seconds, switch to read write. Yeah, I could also go for read execute first, then change it to read write, and then change it back to read execute, because then the initial protection is read execute and the last protection is read execute, which would also be better. But we can improve it anyway later. I would first like to have something which is working and which is simple, and then we can see from the time we still have, or I still have, on how we can improve this. No problem at all. Okay, so now we're going to change protections from read-write to execute read. And as we don't want to use... perfect, this is exactly what I wanted to have. I don't want to create a thread on this memory region, because creating a thread contains some ETWTI events. It could be detected by userland hooks. Defender is not using userland hooks, but a direct pointer is much better here in this specific example, because a direct pointer is no Windows API is used, so there is nothing which could be monitored on runtime to check what is in this specific buffer location. If we go for a direct pointer, that's perfectly fine. Okay, we are reading the file, we're decrypting it, we're allocating memory, writing the content into memory. Most sandboxes will fast forward these wait sleep functions, right? That's a good question. It depends, and you also, how should you verify this? So if you upload, what I did in the past was, for example, I did use regular sleep, so the Windows Sleep API to sleep for 100 seconds or something. And if you upload your payload to VirusTotal, then there are some engines which run into a timeout, and others, after a very, very short amount of time, already find the correct payload. But this might be because they skip sleep or wait, but it can also be that they just analyze the binary, they find there is some key value, there is some byte array which might be encrypted, and they decrypt it themselves, or they run it in an emulator or something. So it's not that simple anymore today, I would say, to just have this sleep fast forward thing. There's many more things which we may need to integrate later to get rid of such detections. Okay, but this, in the very end, if I'm not completely mistaken, should already be a working loader. I don't want to. We don't want to do it in. We are not doing it in C, but we're doing it in C++. Okay. I guess we will have the same issue as we had before with the encryptor that we have. Oh no, it's instantly working. Okay. But this doesn't mean that our C2 connection will also work. By far not. Maybe the decryption is not correct. So why is Havoc broken now? Okay, this looks better. Let's just see what happens. Okay, we need some more verbose output because this is not working yet. And now, because there's an issue here, return 1, print error message. How to print something in, is it printf? Printf in C++? As I said, I never use C++. Scalsack! Yes, it's in stream within business hours. I'm currently in parental leave, so I have enough time and I can spend some time in business hours. Yeah, this is not. I'm not working in this moment. Okay. So we will see if this first thing here already failed. Looks like not. So the buffer is not empty. Reading the file looks like it worked. Then I'm going to be super stupid. Decrypting buffer. Buffer decrypted. We don't need one more print statement here. Memory allocated. Buffer written to memory. Protection changed. Then we can see if it failed and if yes, at which point. Okay, this looks good. But then I guess that the decrypt function fails. Because if the decryption is not working properly, then it will crash. I think we have the same variable names here, right? Encrypted file, right? No, I don't want to write anything. Is this the encryption? I think we could, or we should be able to use this same function here. And we just do it like this. Okay, we'll just go for this. And we don't want to write it anywhere, so this has to be left out. So all of these AI suggestions I'm just accepting all of them for the moment to just see what happens, but it looks like this doesn't result in something good. I guess there's multiple issues here. This will never work. I don't think so. No. But we want AI to write this code. So let's just put the error message to GitHub Copilot. Unsigned char to char, which is not allowed, buffer pointer as unsigned char. Oh, same issue we had before. Unsigned. If I was a good coder, I'm not, then I would now try to find out what the difference is between signed and unsigned char. I'm never using those, or I don't think something similar in the other programming languages I was using. This doesn't solve it. Okay, it doesn't solve it, so let's try something else. Can you fix this code, please? This is the encryptor. This is the decryptor. The good thing with GitHub Copilot is, in the very end, you don't need to know anything, and there is no ethical restrictions. If you try to do the same in ChatGPT, you will instantly need to have some sort of bypass, because it always states what you want to do here is not ethical. You cannot copy some shellcode into a memory region and execute it. This is potential malware development. But if you use GitHub Copilot, it just works, and it just outputs you something. It's far away not always correct. Far away from being always correct, like this. But it's not restricted. It just gives you something regardless of what you're asking. I rarely had the situation where it told me I cannot do this for ethical reasons. Maybe there was a comment in the very end, please don't do this because it's not ethical, but nothing more. This looks good now. Okay, I think it successfully fixed the code for me, and I don't even have to think in the moment. I don't have to think what I'm doing because I'm always asking AI. I'm not thinking about the code. This is like a super bad script kiddie could have done the same by just writing some comments and by pasting error messages into the chat prompt. We got a connection now. So we got a working Havoc connection now. So let's just for the sake of fun. How long did this take? Do we have some time here somewhere? How long is the stream running? Cannot tell. When did I start? Half an hour, maybe? So half an hour, and we got a working loader written by AI. AI Maldev. This is our loader code. The desktop is not at all excluded from Defender or anything. So if I paste it to the... So there is no signature for this loader, looks like. I can also execute it from the desktop. Ah, now Defender found something. This is where it might get interesting. Yeah. Okay, now it tells me this is dangerous and executes commands from an attacker with our executable. But WACATAC, whatever, this detection is a generic one. It's not a signature for the file, but it's a generic detection, which is just like something was decrypted, something was allocated and written into memory. And on the other hand side, yes, there is a detection, but it's still alive. It was not killed at all. But we can make it better, I guess. If Defender finds it now and we still have some time left, we can improve. Okay, now it says this is a threat, but as all this here is just for fun. I just want to show what we can do in which amount of time by just leveraging AI. This loader, of course, does not contain the Havoc shellcode. So it cannot be detected by a signature for the Havoc shellcode, because the Havoc shellcode is on disk in an encrypted binary blob. So if we upload this to VirusTotal, no one can say, okay, this is an Havoc daemon, because the Havoc daemon is on disk on my system. But I still would like to know how many detections we have with this version already. Come on. Come on. Solving captchas in a stream. Wow. What's wrong? Why so many? Okay, so we just generated a shellcode loader with AI in half an hour, which gets 3 detections on VirusTotal. I think this is quite good for the beginning. Okay. Of course, one thing which is which stands out here is the print statements and the strings in general. So if we have this decrypted buffer decrypted, okay, there is nothing about shellcode, nothing's mentioned about shellcode or something, but this could be removed. You don't need to have any strings in malware. But maybe we can also get rid of these machine learning detections, but they should be, I guess, somehow be related to reading something from disk, allocating memory. I mean, these sandboxes all fail already when the file is not successfully read from disk. So this here already is a good thing to avoid sandbox detections, because typically if you put a payload somewhere on disk on some system, if it's an executable, it will get thrown into a sandbox and will get analyzed. But if your shellcode is in a dedicated file, if it's not embedded as a byte array, it's super hard for the sandbox to find out which file from disk to also put into that sandbox and which file to also embed there. And it will never see the actual normal shellcode. So this is quite good already for sandboxes. And this is also the main reason why we get free detections on VirusTotal. If we change this, and we can do this, to our encrypted payload. So I think this here is a feature to say, give me a byte array, copy as. Yeah, that's it, I guess. So I can say this is my encrypted daemon. I want to copy this as C. And then I get the payload. So this is the alternative, and this is what most shellcode loaders do. They have the shellcode embedded in the payload. So you have an unsigned char array of the size here, which is embedded in the payload, and this is what you should. You can do it, but it's less OPSEC safe. Because it's super easy for a sandbox to analyze this buffer. Is it named buffer? No, it's named raw data. So instead of raw data, can I just decrypt this the same way? I hope. Buffer raw data. Oh, there's a lot of buffers. Maybe we should just rename it to buffer. That's easier. Standard vector byte cannot be used as unsigned char. Let's not think about it, but instead take the error message and ask AI on what to do. Maybe we can just cast it. Maybe we need to generate a new vector byte and put it into this. We will see. Okay, so it generates a new vector, it puts the buffer size into that new vector. A new vector is generated, the buffer is put into this new vector, and we decrypt the vector. So this is the solution according to AI. It compiled. Now we should see that the size significantly increased. Now it's nearly double the size, which is obvious because we have a byte array in this loader now, and the byte array is our Havoc shellcode, and it also fails. It fails directly. Something is wrong again. With size of decrypted Was this a detection by defender now, or let's just see if this is because it's detected. No. So something with the decryption is wrong again. Anyway, uploading this to VirusTotal, this newly generated file, should, in theory, and in praxis, even though it's not decrypting correctly, not yet, lead to many more detections, because some engines are capable of decrypting the shellcode correctly themselves. I need to solve a lot of captchas again. Google, Icarus. Google and Icarus were not included before, but as you can see already, I don't want to go for this anyway, so I'm not going to fix this now. Let's go for some other things. But we have 9 detections now, although it's not decrypted properly. This captcha stuff really sucks. But I also still don't see any Havoc specific detection, which is what I'm really wondering about. Anyway, we stay with the previous solution. Just wanted to show you what the alternative would look like. And we can get rid of this buffer like this. Okay. We need to remove this again as well, and we need to use our buffer again here. So, we had 3 detections on VirusTotal with this loader here. Which is already quite good. Let's go for something really simple. Something really simple, but which has quite a good effect on getting even less detections, is to build an DLL instead of an executable. Can you provide a DLL main function for C++, please? And if we want to compile to an DLL, we need to have to expose some function. Typically, we will expose or export DLL main. And as I pretend to be completely stupid here, and I indeed have no knowledge of C++, I'm just asking for a DLL main function here. I can copy the code. I think we already included Windows. So now we have DLL main here. And I would like to do all this stuff which was done before in the main function in DLL main instead. Let's just call this function runner, and then we can call it from here. So if the DLL is attached to a process with DLL main being called, then we will call runner, and runner will do all this stuff here. It will get the file from disk, it will decrypt, it will put the shellcode into memory, change the protection to page execute read, and it will execute. Let's see. I guess this is at least something I think I know, is we should be able to get an DLL with minus shared. I think it works like this. No? DLL main runner was not declared in the scope. Do we need to declare the function before DLL main? Yeah. Okay, now we have a DLL instead of an executable. And I can only recommend you, if anyone is doing some malware development, and many of you probably are as your pentesters or red teamers, it makes sense to use DLLs instead of executables. Don't use executables if you don't have to, and you typically don't have to. I'm typically always programming in NIM or a lot, so I'm often using nim main as an export function, but in this case we can use DLL main. We should also be able to just call it without any function name with run DLL32. Should work the same way, because DLL main is called by default. But this is not working yet. This is also not working. What if we just say call runner regardless of the reason for DLL main being called? Statement will never be executed. Because it's a switch case. Yeah, okay. Makes sense. Permission denied. Okay, now we have another potential issue here. Namely, it's running. We have some run DLL32 process which is running, but the shellcode is just not executed. Let's kill all run DLL32 processes. Regenerate it. And try to do it again. Same effect. Do we need to create a thread on the runner function to escape from loader locks? Let's try to do that. Create a thread on runner with 132 create thread. And I instantly get the recommendation from GitHub Copilot to use this function like this. We don't necessarily need to wait for this new thread. I think we had the problem. Yeah, that should be it. We exposed DLL main, we called this function, and the function made a direct pointer to Havoc. So it was stucking at this point, and DLL main never finished. If we create a thread on the function instead, we should not have this problem, regardless of if we wait for it or not. Ah, fuck. I didn't saw the chat for some time because I clicked into it. There was a lot happened there, sorry for you guys. Yeah, you should not create a thread from the loader look. Yeah. As an alternative, we could also just not use DLL main. We could also just export another function and call this from the other function instead of from DLL main. How to export a function in C++, not DLL main custom one. And then we don't have this loader log, DLL main, whatever, all these kind of problems with DLL main stuff. So we can use this one here to export a function. My function calling runner in a new thread and waiting for it. Create thread on runner, wait for single object, infinite, perfect. This should do it. Without DLL import attribute. Okay. DLL import attribute. I never did this before. As I said, for those who are new into the stream, I never used C++ before. I'm just pasting everything into the chat and accepting all the stuff which is recommended by GitHub Copilot in this case. I don't see any modification. It's the same, isn't it? Ah, DLL export instead of DLL import. Yeah. Okay, that was quite simple. Yeah, yeah. My function. Now we try to call my function instead of DLL main. Let's see. On. Huh? Reading the file. The file is still there. See, don't scan. Still there. What am I missing? Printf? Is printf a problem when using DLL because nothing can be printed? Is this a problem? Potentially. I think normally it should not be a problem, but And I need to change DLL main. No, I don't need to change DLL main. It just returns my function. What am I doing wrong? Create message box prompting user to press OK. Message box success. Let's see if this function is called correctly and if we get a message box. Okay. So this is not a problem, this part. Maybe the problem is that we need to wait for the process. So the process should still be alive and should not quit. Yeah, I think run-dll32 just quit and the thread was successfully created, but it's not correctly waiting for it. This is my current guess. So we can use wait for single object -1 but I think we have to cast it to handle then. Is this possible in C++? Yes, looks like. If we do -1 and infinite, it should wait. It should never quit the process, but the process will still run. Yeah, that was it. Weird issues in between. Or I could leave the message box open. Yeah, that's true. Should have the same effect. Okay, so now we have a DLL instead of an executable. And we have a message box prompt. In real malware you would not use a message box prompt because this would be, or maybe depends on the payload. Maybe sometimes it could make sense to still use a message box or something to prompt the user to press OK or whatever and execute the malware. This could be used for sandbox evasion, but I don't want to let it stay here. This was just for troubleshooting purposes. So let's upload this DLL to VirusTotal to see if this already changes something about these 3 detections which we still had. You would use a message box prompt, Scalesec. How often do you pish users in reality? DLL 1240. I'm going to upload this to VirusTotal just to see if we have a different detection rate for DLL. Just DLL with basically the same code but in a specific exported function, not in DLL main. If DLL to executable makes a difference here. I mean, for the sandbox it would actually make a difference to have the message box in there. If there is a message box, the sandbox cannot click it. solving lots of captchas again. Elastic. Ah. Did Elastic flag the first one as well? No. Huh. Elastic and Cynet. In the previous loader. If I prompt the user to solve a captcha, yeah. This is interesting. We have some, but it also, no, I don't think it's due to the previous uploads to VirusTotal that they learned it that fast. I'm not sure, but you never know. Okay, so if you want to avoid signatures for any vendor but not for MaxSecure, Symantec or SecureH, you can go for the loader, for the executable. And if you want to avoid all the engines but not Cynet or Elastic, you can go for the DLL, looks like. Yeah, but I would always recommend to use a DLL instead to execute this with some Windows native binary or with side loading. Yeah, this is what one person mentioned here already. But I will not be able to write a packer in 2 hours which parses an original DLL's exports, builds, puts all them into our loader, and so that we can use DLL side loading here. This won't happen in 1 hour or something, I don't think. Behavior analysis. So, what do we have here? Shared modules, parse PE header. I'm not parsing the PE header. This is get file size, yes. Delayed execution. Because it doesn't see that something is executed, so there is a neat Windows Defender sideloading vector still unpatched by Microsoft right now. I don't know what you're talking about. You would need to provide some more information about... you mean just a Windows Defender executable which is vulnerable to sideloading? We can actually go for... I have an idea. We can go for sideloading, just for fun. Because there are some nice projects which... yeah, you can use so many binaries for DLL sideloading. You don't necessarily need to use Windows Defender. If you just scan... I made a tweet somewhere... months ago, maybe a year ago. Yeah. So if you search for, I can only recommend you to not use any sideloading binaries which are publicly known, but to instead search for new ones. And you can, for example, use Seofra. This is one tool. To just scan binaries, and it will tell you which modules, which DLLs are loaded, and if it's if the executable is vulnerable to DLL sideloading or not. And this is what I did for almost any executable I found so far, and I have many big, don't know, 100 megabytes text files with just output from Seofra. you can use DLL sideloading for many different binaries. It depends. If the binary is flagged here by Elastic, that does not mean that Elastic would actually delete it if you drop it on disk in that moment. Because sometimes you have, I faced this with CrowdStrike, for example. Sometimes you have detections on VirusTotal for a binary or for a DLL. But in reality, if you drop the same payload onto a system with this solution, it will not get flagged or deleted. On VirusTotal, they flag more stuff than they do in reality. So this doesn't mean that it would not execute against Elastic, but it will for sure, and I'm really sure, this payload will lead to alerts and maybe also get killed by Elastic because we are allocating unbacked memory for Havoc. And this will be detected on runtime. So if you don't stomp, if you don't use module stomping in your loader, we could integrate module stomping. This is what we could do, for example. Instead of allocating memory, we could try to integrate module stomping with some time. If a call comes from a known process, it sometimes helps. Yeah, this is true. But the problem is we cannot, or we could upload a zip archive, for example, or an archive archive in VirusTotal, which contains the binary and the DLL. But yeah, this is the, let's say, border of what is possible to check on VirusTotal. Let's do it the module stomping part. Let's first go for a short trip to site loading. Coupling. So there is a nice project called coupling. And this project contains a sub-project netclone, which is a C# assembly, which can pass. It can pass a legitimate Microsoft binary and pass the exports and patch an existing DLL to apply these exports to the existing DLL. So what we could do here is we could use netclone. Oh, there is some DLLs that are missing. Okay. There's a lot of DLLs missing. I have to spam this folder with stuff. Okay. Target C Windows System 32 version DLL. Wait, no, I'm wrong. Our target is the binary we just generated. C stream AI Maldev. We generated a DLL which is named loader.dll, right? Yes, loader.dll. And the reference binary is C Windows System 32 version DLL. The output binary is again our loader DLL, and now we patched our loader DLL and applied the exports of version DLL to it, so that we have the same exports as version DLL, and all these exports are forwarded to the original DLL so that it's still working. We can verify this with, for example, DLL exp. If it's here, I hope it's here. It's not here. My system is full of trash. Don't blame me for that. DLL export viewer. But if we do it like this with netclone, we have another problem. Stream AI Maldev loader.dll. Yeah, and as you can see here, now we have all the functions from version DLL exported in our DLL, but they will get redirected, forwarded to the original version DLL, so that this can be used for side loading. The fan sound is indeed my computer here, which is many years old and which is super loud. That's me. Yeah, but we have one more problem here. If we are going for coupling or netclone, we have to use DLL main for our payload. And with having to use DLL main for our main payload, we have the same problem we had some minutes ago with loader lock and all this kind of stuff. I mean, the binary will not start if we do it like this. Let's just do it for a moment. I would just in DLL main do the same thing we did in our custom function. And I have to recompile now. And after recompiling, I have to reuse netclone to patch our DLL. And now, in theory, oh no, it's not here, it's here, AI Maldev. How to fix it, I can tell you later. My personal solution in this moment is to not use DLL main. There is blog posts, there is techniques, there's a lot of stuff telling you how to do this or what to do, but in the very end, I think not using DLL main is maybe the easiest solution. What did I want to do now? I forgot about it. Yeah, we are going to copy this generated loader DLL to C users. Username, local, Slack. Slack is, for example, vulnerable to DLL side loading. And we will copy it here as version DLL. And now our malicious binary is in the Slack folder, and if we execute Slack, it will not start correctly because it will hang in DLL main because of the loader lock, I guess. Normally we should also get a connection here from Slack after doing this. Slack died. Yeah, perfect DLL hijacking. I know about this blog post and I implemented this in my private packer, this technique. And even when using this technique, you will have a lot of problems with... so this is not the perfect solution, at least not for me, and at least not for what I was testing so far with it. So I was troubleshooting this perfect DLL hijacking blog post and this technique, and I still had issues. I still had issues with Slack, I still had issues with other binaries I was testing with, and this was not the solution for me. yeah, the dynamic way is what I'm also aiming for at the moment, and I already got a working solution on how to do DLL side loading without DLL main for one specific function, and this is what I just posted on Twitter, like, I don't know, in the last week. Because you can do all of this stuff. Okay, this is not up to date. You can do all of this stuff. How did I name it? I don't know. If you search on Twitter, I'm not logged in here on my lab system. If you search on Twitter, I posted some stuff in the last week on how to build a function, a custom function, which exports what you need to do this. But I did do it in Rust, and it's a project which is not published anywhere, so I cannot really show it to you now. It's also not on this VM, but it's possible. Also without knowing the function definition, without knowing how to call the parameters, all this kind of stuff. It's not necessarily needed. But I would still like to have this working here. I don't like the fact that it's not working at the moment. So this, at least this should normally lead to a C2 connection at least, and not to a process crash. Or I could try to, maybe it's also related to Slack, and I can try it with OneDrive, for example. It's a little bit more stable than Slack. But now I'm not coding anymore, but I'm instead talking about different stuff. OneDrive. I think it's this folder. OneDrive is at least more stable than Slack. No, the AI is not doing much anymore because I'm talking about theoretical things instead of actually coding. I'm going back to code. I did a dedicated video for DLL side loading. If you're interested into that, I think 1 year ago or something I did it. It's 2 or 3 hours only side loading. If you're interested in it, take a look at this. Maybe from what I was just talking about, maybe I will write a blog post or something similar later to the custom export and this kind of stuff. But I would like to get back to some coding here for the next, I don't know, half an hour or something. The video is on YouTube, yes, on my channel. Okay, now Visual Studio Code is not responding anymore. This might be from time to time, I guess, due to the plugin, due to GitHub Copilot. I had this from time to time since I'm using this plugin. If you search for secure this shit on YouTube, you can find it. Then you'll find all public videos. Let's try to implement module stomping for the next. Here, this is it. Okay. I'm not going to use DLL main anymore. I'm not going to use. We can stay with my function, and we can try to go for module stomping. If we go for module stomping, we will not use virtual alloc anymore to allocate memory. Module stomping function, which takes a DLL name as input, loads this DLL via load library A, and returns the, what do we want to return? The start of the text section, because this is what we want to overwrite. Which is Linux as plus base address. In theory, as simple as that. So we want to create a module stomping function which loads a DLL, which has a DLL parameter as input. It uses load library A to load this DLL and will return the text section start, which is typically 0x00x1000 plus base address. So module stomping, DLL name, load library A looks good. Getting the base address, which is the output from load library A. It can also be done like this. So we can also hard code the base the text section start, but this might also work. Let's go for this approach because this is what AI suggests. And I said in the beginning, I'm accepting everything which is which AI is telling me to do. Okay, so we are not allocating memory anymore. We don't need this anymore. Call module stomp function with C Windows System 32 chakra DLL as input, and so we call our module stomping function, and all these auto-completion stuff here, all this is AI. So I'm only writing a comment to say what I want to do, and then I'm accepting what is given to me. So this should, in theory, lead to us getting the text section start of chakra DLL and chakra DLL being loaded. After that, we need to change the protection. The text section is typically Rx memory, so we need to change this to read-write so that we can override it. P decrypted buffer to read-write. So we can use virtual protect to do that. Page read-write instead of read execute. Then we're going to, this is already correct. So the P decrypted buffer is the correct correct address on where to write the shellcode to. Then we go to overwrite the text section with our shellcode, or the part of the text section which is size of our shellcode. And after doing that, we need to reprotect to execute read, which is already implemented. So in theory, this is how to module stomp, the easy way. I would like to still get back to executable for the moment, just for troubleshooting purposes. Int main call runner return null. Yeah. And we are going to comment out the DLL part for now. because then we still see what's happening if it fails. Okay, we're not creating a shared module anymore, but we're creating an executable. Let's see if there is some syntax errors or similar. Blah, 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 blah. Okay, redeclaration of old protect. This is the simple one. This here is something with casting, or I guess. So as I did before, I'm just pasting the error message into GitHub Copilot, telling it to fix this. I'm trying to cast pointer reference to void to D word. This is not possible, so here's how we can fix it. P-image and T-headers. It's this part here. So it's just about the casting. Text section start. Also just about the casting. This will allow your code to compile. The second one was old protect was declared 2 times, right? Keyword old protect. We don't need to declare it a second time. We can just uncomment this. Okay, now it compiled. Let's see if it also executes correctly. Okay, you can see that it at least does the initial check-in. Let's see if it's still alive. Yeah, that's healthy. That's good, because we can now verify if our DLL was loaded, so our module stomp DLL. And as you can see here, in this process, Chakra DLL is loaded. And this is good. And on the other hand side, we can check the protection of Chakra DLL. Because we should now see, this is not the perfect implementation. But here you can see now that (240 kilobytes). Normally we can see that this is this was marked as private or something, shared. So I think this has something to do with the shellcode. Looks perfect. Yeah, it looks good. And the Havoc shellcode should be in the start, so it should be somewhere here. Yeah, this program cannot be run in DOS mode. It's here. So this is our Havoc daemon DLL and or reflective loader. So this is module stomping implemented by AI. Just by writing some comments on what to do. Of course, if your C2 payload, like Havoc, doesn't use module stomping on its own because it's a reflective DLL, so this reflective DLL allocates new memory and writes itself or the core into this new memory. So this is again unbacked memory. You would need to modify Havoc to have completely stomped memory, and in this case it's just the header and start bytes took a bit off. Yeah, it's not the exact start position of the text section. I think it would be, so from my knowledge, it would be as easy as changing this here to plus something with the parsing here went wrong. But this should be it. And it should be this start of the text section, if I'm not completely mistaken. invalid. I cannot. Okay. Let's ask AI. I'm writing one line of code myself and it's wrong. Yeah, the sliver shell code will not work for obvious reasons. If you only have 5.5 megabytes of text section, you cannot override it with 16 MB sliver. This will not work. But maybe, I never tested this, if you check, there is DLLs with much more space than Chakra DLL. And if you go for some other DLL, which is, where are the DLLs? It's not sorted in size. Here, this one here, for example. Maybe I would need to check the text section size, but maybe it's enough. So this could maybe work for Sliver. I never tested. I don't know. You need to check the size of the text section here. Okay, but this should at least lead to us getting the correct offset for the text section. And now we implemented module stomping. What else could we implement? Someone was talking about. Yeah, or you can stomp with something else and not with a DLL instead. Someone was talking about sleep. To do some sleep to avoid sandboxes. We can also do that. Custom sleep function that doesn't use Win32 sleep, but does some calculations for a given amount of seconds. This way, if sleep is skipped by sandboxes, or fast forwarded, the malware will still wait for the given amount of seconds. Yeah, this was auto-completed by AI. Okay, this implementation will not work. If we pass seconds as input and it just calculates E++, this will not work. I don't know how long this implementation will calculate, but it's just about fiddling around with the. So we just do some calculations instead. I'm going to put the print inside again. Print, we are going to sleep. And sleep for 10 seconds, custom sleep. This will not be 10 seconds never. But we can just fiddle around to see how long it will take to calculate this. Okay, this was maybe half a second. So if we change this value here to 100, then it should be 5 seconds maybe. Oh, it's even longer. Okay, now we implemented a custom sleep function, which is not using Windows APIs to sleep, but which is instead doing some calculations. So if some sandbox is I didn't implement it, AI implemented it. This was just written by AI after I wrote the comment. We could adjust this to, I don't know, 1000, then it will take several minutes to load. And with several minutes of custom sleep time and doing calculations, this will bypass Sandbox runtime checks, because they won't emulate it for however a long amount of time. How do we call our malware? Update exe. Of course, yeah, I can upload it on VirusTotal. So the first two implementations, after 13 minutes of coding had 3 detections on VirusTotal, the executable, and the second implementation, this one here was with a Havoc byte array included, and the DLL had 2 detections, only Cynet and Elastic. And I would like to add, I can upload this one here, and then we can add another check. So it's called update.exe. Let's see. So we had max secure and secure age here as well. So this seems to be some kind of, I don't know, generic detection. Yeah, but this is the end result. 2 detections instead of 3 with just the plain loader. But we have to say the shellcode is not embedded here. The shellcode is loaded from a dedicated file on disk, and this is what I would recommend you anyway, to get rid of sandbox detections, to have a dedicated check. Yeah, it's quite good detection, yes. A quite good detection rate for, yeah, now it's 1.5 hours of coding maybe, plus some small talk in between. If we want to have further evasion, what we could also do, and one thing I really recommend to do for loader, for anti-sandboxing, is to I didn't implement it, AI will not hold up. Yeah. Can we try it on VirusTotal? Fully undetectable is not possible at all, by the way. So if I upload it now, after 1 or 2 days it will have completely different detections. Nothing is fully undetectable, everything is detectable, but maybe we can reach 0 detections on VirusTotal. But then I would need to find out what exactly is triggering these 2 remaining detections here. Another sandbox evasion feature, which is checking if the current system is domain joined or not. If it's not domain joined, crash the current process with a direct jump to 0x0, whatever. So this is what AI recommends to check if we are domain joined or not. Get computer object name. And this is how to do inline assembly in C++, maybe, looks like. I never did this before. Undefined. check if domain joined. Now we are not using, it's also not a bool. That's okay. We commit features, yeah. First, let me first finish this one here. I wanted to know what it does for the domain join check. And I'm pasting the error message here again so that I can, or that it fixes the potential issues. I think there is some import missing here at least. Yeah, this is also what it tells me. Some imports are missing. And we need some more DLL to be linked. Secure 32lib, security, LM, whatever. Let's import those. AI states, we should import those. ASM are not recognized. Inline assembly is not supported in C++. If you are using MSVC, how to do inline assembly with G++? Fix the jump. Let's see if this import is not missing anymore. Okay, I think this is the point where we will have a lot of more errors and more errors if we follow the AI recommendations here. Exit failure. This is the first time where it states this is more safe and more portable to exit the program instead of jumping to a non-existent address. I still want to do it like this. Include standard lib. I don't think standard lib is the fix for this one here. UD2. Okay. But this will lead to an issue. Okay. I'm really not thinking in this stream. I'm not thinking at all. I'm just pasting error messages here into this, maybe a little bit in between to write comments, but get username X. Change to get username X. Qualified domain name. Will this also work? Just accept it. Undefined reference to get username XA. Come on, why is this not declared? Where is it? And this is a message by the linker, not by... Okay, I removed this and now... no, I don't want to provide this manually with compiler commands. Secure 32. Come on. Doesn't fix it. It stated to me min.gw does not support this, so I need to add it to my linker flags. Really? Okay. Okay, but if we execute this now, it should... oh, I should adjust the time to a different amount, or we have to wait a lot of minutes. Yeah. So now our shellcode is not executed anymore, but instead it's this here, which was recommended to be used because it causes an illegal instruction signal. Okay. Okay, so we have a domain join check now, and if this fails, it will also not execute. So there was one recommendation or one idea what to do next. One or two people said let's go for fully undetectable. Someone else recommended something. What would you like to see in this loader now? We already did DLL. This was done, I don't know, half an hour, 45 minutes ago. I just uncommented the code, but this here is the DLL code. You can watch the recording if you want to see that later on. DLL is already done. It's just uncommented now. But I can ask AI. This implementation still has 2 detections on VirusTotal. What features would you add to get 0 detections? Direct syscalls. I don't have that much time anymore, and I'm sure if I ask GitHub Copilot to implement direct syscalls for me, it will have a lot of issues in the code. If it's getting more complex and if it's not just single functions, then it will get too complicated. Obfuscate your code. Anti-debugging techniques. I don't think anti-debugging techniques will lead to 0 detections here. No way. Anti-Sandbox is already implemented. What we did here is basically a packer, a very small packer with an encryptor and a loader, but still. Rootkit techniques. Yeah, this is if you're going to ask some things like this, you will not get proper answers by GitHub Copilot. what means heavy environmental keying. I think so. I'm actually sure that these detections here are somehow generic, and our environmental keying, it's not real environmental keying because we don't check the target environment. I would need to check the current hostname and the current user, for example, and only if this is true, or only decrypt the payload with current hostname, current user or something, this would be environmental keying. But I think that the checks we already have implemented in here are enough. So this custom sleep function, this domain join check, this is perfectly fine already to get rid of common sandbox detections. We have module stomping implemented already, at least a very basic implementation. The shellcode itself is not... Yeah, thank you for joining, Scarsec. Have a nice day. But I think these environmental keying stuff that we did here is already enough. I think maybe with custom code, custom functions that do custom stuff, just more code, or pumping the binary with whatever. This could be HTTPS loading of shellcode. Yeah, this is just an alternative to getting it from disk. I mean, I can, just for the sake of fun, a function that loads our shellcode from a remote HTTPS web server. The URL, to make it easier. The URL is provided as input parameter. The return value is the byte array of the downloaded binary. Let's see what GitHub Copilot in ASM. I think that's these things are too complex for it. Okay, now there's DLLs and imports missing again. Carbocan is makes sense for remote injection. Mainly, it's to avoid memory scanners for if you inject into a remote process. And here we are not injecting at all. We stay in the local process, which is much more OPSEC safe anyway. Yeah, but this is the implementation on how to load shellcode from a remote URL. What to import here to get the imports. Yeah. I don't plan to test this now, because yeah, it's just a different, an alternative implementation to loading it from a local file, which we already have. If we load it from a remote web server or from a remote file, it doesn't make that much difference from my perspective. But this is what probably works, and what is the solution from GitHub Copilot. Just for the sake of fun. Yeah, so this is what according to GitHub Copilot, the custom inline implementation of get proc address and get module handle. So it just uses get module handle and get proc address, which is not a custom inline ASM implementation. It's far away from. But this is too complex, as what I said. If you say I want to do something with ASM, it also states, yeah, this you should not use ASM. This is unsafe, and so on and so on. Inline custom inline implementation for get proc address, and it should consist of ASM inline code only. Push function name, push DLL name. A little bit more near, but still far away from what you expect to do. I think you're expecting to pass the PB and this kind of stuff, right? I mean, pushing the stuff into the registers as parameters and calling the function could work, but it doesn't really make a difference. This is not full inline ASM. Yeah. 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 I want to try one last thing. I don't have that much time anymore. And I think the code is already quite good for the short amount of time, as we can see from these results here. But I would still like to see if we can get rid of these two remaining detections. A function that just holds a lot of random words in an array and does calculations with them. This is just to add noise into the binary and to have more legit looking strings. This is a test string with random words to add noise to the binary. Main calls runner. Runner does all this stuff. We can call the random words function. Another random words function which holds different random words. I want to just pump the binary with more random words. Now GitHub Copilot takes some longer time to load because it needs to calculate. This is not random. Binary. What's wrong now? Do I need to have a comma in the end? No. more random words, and we're going to call this, I don't know. This will not be executed at all by the sandbox, because it should so we call more random words here. Another function. Let's just see what happens. Call it updates now instead of update. Okay, I'm going to remove we need to link another DLL. I don't want to link this DLL now, I'm not using this feature at all. So let's remove this. So now we have updates.exe. How much bigger did it get? Updates. Wow, this is nearly no difference. Nearly no difference. This is bad. This is bad. Is there a way of in C++? I can ask AI, obviously. Can you embed a DLL from disk, from the CUD, into the compiled binary on compile time in C++? It should be embedded as a char array, whatever. Okay, that this works is obvious. I don't want to load it on runtime, I want to have it embedded as an array like this. In the other programming languages I'm using, there is always a function which can do this. Never mind, we have hxd here. I'm just going to say copy as byte array. Now I want to just pump the binary with some stuff. So that it's looking more legitimate, maybe, to these two vendors which are left. Raw data. Okay, now maybe we have to do something with raw data so that it's really embedded in the binary, I don't know. Or we can also try to just compile it and take a look at the size. Okay, it got exactly that size bigger. Let's try. Updates.exe. Nope, elastic again. And secure edge still. but the entropy of the DLL, which I just added here, should be perfectly fine because it's some legitimate DLL. But yeah, I don't really have time left, so I'm quite happy with the results from today already. Just to sum up, after like 30 minutes, yeah, the X bytes are not usual. It's also not usual that an DLL is embedded in another executable, but yeah. But as I don't have super much time left anymore, I'm just going to quit for now. I think I'm happy with the results already. I mean, after half an hour, we got a loader which had an executable, an unsigned executable, which had 3 detections on VirusTotal. This one was with the shellcode embedded, so obviously some more detections. After a little bit of more time, we got a DLL, which had 2 detections, and which was different vendors. So if you need to avoid one of these vendors, you could go for the DLL solution and vice versa. Yeah, and now it doesn't make so much difference anymore if we switch a little bit. So I'm happy for today. I think the result is quite good for not really thinking but just writing some comments, and yeah. Now you could, for example, automate this kind of stuff, combine the encryptor and the loader so that the encryptor has a random key, the random key is different each time, and it builds or it modifies the loader CPP so that the key is changed there, that random stuff is added, and so on and so on, and you could basically build your own packer the same way by just asking more and more questions to AI. And in the very end you would have a working packer, mainly generated by AI, which is quite fun. So, fun experiment. I'm happy for today. If someone, I don't know how many people are still there, or at least one who's writing something into the chat. Yeah. Okay. I'm going to upload this to YouTube later on so that everyone can watch the recording. And have a nice day, everyone. Bye bye. And nice that you joined.